When you think NASA, what comes to mind? Probably astronauts, Mars rovers, maybe the moon landing, right? But what if I told you that some of their most important life-saving work isn't way out in space, but right here in our own skies? Today, we're diving into the hidden legacy of NASA's aeronautics research, the incredible behind-the-scenes science that has quietly made flying the safest way to get around the planet.
It really is a wild thought when you stop and think about it. You're blasting through the air at 500 miles an hour, 7 miles up, and yet you are statistically safer than you are driving to the grocery store. Now, that incredible safety record didn't just happen by magic. It was built piece by piece through decades of intense scientific work. So how did we get here? Let's get into it.
So, our first stop is the battle against an invisible and often deadly enemy, the weather. For a long, long time, pilots were essentially flying blind into atmospheric conditions they just couldn't see, and the consequences were absolutely devastating. Okay, so picture this. It's a stormy afternoon, June of '75 in New York. A Boeing 727 is on its final approach into JFK. Everything seems totally normal. And then, just moments from the runway, the plane slams into the ground. 113 people are killed. And the scariest part? This wasn't a one-off. Similar accidents were happening, and investigators were desperately trying to figure out why. And the culprit turned out to be this terrifyingly powerful and totally invisible phenomenon called wind shear. Basically, it's a sudden, violent change in wind speed and direction. For an airplane that's low and slow, like on a landing approach, hitting something like that is like having the air itself yanked right out from under your wings. Now, the most dangerous type of wind shear is something called a microburst. Just imagine a massive column of air falling out of a thunderstorm, hitting the ground and then exploding outwards in all directions. A plane flying into this gets hit with a massive headwind, which is fine. But then, just seconds later, it punches through into a massive tailwind. Airspeed vanishes, lift disappears, and you can see how that ends. So, to solve this deadly puzzle, NASA put together a team that got the awesome nickname the Burst Busters. And their plan was both brilliant and, well, incredibly brave. First, they built computer models of the past crashes. Then, they put brand new sensors on a Boeing 737 test plane. And this is the crazy part. They then flew that plane, on purpose, directly into thunderstorms, over and over again, hunting for microbursts to prove their tech could actually work in the real world. And the result of all that unbelievably gutsy research, it comes down to this number, 20 to 40 seconds. That's the warning time the new Doppler radar systems gave pilots. Now, that might not sound like much, but let me tell you, for a pilot in that situation, it is an absolute lifetime. It's more than enough time to slam the throttles to the firewall, pitch the nose up, and fly right out of danger. This wasn't just theory, it was a practical tool that saved lives. All right, so beating the weather was a massive leap forward. But there was another, equally tricky problem to solve, this time inside the cockpit. See, as planes got more and more advanced, the connection between the pilot and the machine, well, it was getting seriously complicated. And what's really telling is the date on this quote, 1971. Even that far back, NASA test pilots like George Cooper were raising the alarm. Cockpits were turning into this dense forest of blinking lights, complex dials and switches. Pilots were facing a massive information overload. So NASA's human factors research completely changed the game. On the left, you see the old way of doing things, a chaotic mess of individual gauges for everything. But on the right, that's the modern glass cockpit, and it's a direct result of that research. Instead of 100 scattered dials, you have a few clean screens that show the pilots exactly what they need to know when they need to know it. It just massively cuts down on the potential for human error. And it goes way beyond just the hardware. NASA also did groundbreaking studies on pilot fatigue and alertness, especially for those really long flights. You know, this work is the scientific reason we have rules today about how long pilots can fly and how much rest they have to get. It's all about making sure the human being in charge of the plane is just as finely tuned as the machine they're flying. Okay, so we've looked at the weather outside and the pilot inside, but what about the plane itself? Well, it turns out NASA's research has also revolutionized the very materials that hold an airplane together at 35,000 feet. Let's just use one part as an example, the tail fin. For decades, these were made out of metal. It's strong, sure, but it's also really heavy and a pain to manufacture. But NASA's work into advanced composite materials, think things like carbon fiber, changed everything.
This new stuff is actually stronger than metal, and it's way, way lighter. And this table right here, this tells the whole story. Just look at the difference. A metal tail fin could have more than 2,000 individual parts that all have to be fastened together. The composite tail fin? Less than 100. That means it's not only lighter and more efficient, but it's also stronger and simpler, with way fewer places for things to go wrong. So how do we know all these new designs and materials are actually safe? Well, the secret lies in NASA's incredible wind tunnels. These are places where engineers can blast hurricane-force winds, or faster, at new parts. They can push these designs to their absolute breaking point, all in a safe, controlled lab, so that they never ever fail up in the sky. So you see, all this work, on weather, on the pilots, on the very materials of the plane, it all weaves together to create the amazingly safe air travel system we have today. But, you know, the job is never finished. So the next time you buckle up for a flight, just remember this: your safety is not an accident. It's the result of a deliberate, relentless scientific process. It's because NASA scientists literally flew into thunderstorms, re-engineered cockpits screw by screw, and invented brand new materials from scratch. They helped build a culture where we don't just wait for accidents to teach us lessons. We figure out what could go wrong and stop it before it ever does. And that brings us to today. Our skies are getting more crowded, not just with planes, but with drones and all sorts of things. Automation is everywhere. The challenges are always changing. The mission for safer skies, well, it's a journey that never really ends. And it leaves us with a really important question. What's the next wind shear? What's the next invisible danger out there that today's researchers need to find, understand, and conquer for all of us?